a sample of 400 observations. That means n is equal to 400. So n 400 means n is greater than 30. That means large sample taken from a population with a standard deviation 15. So you are given population standard deviation. So sigma is equal to 15, which is known. Okay, so a sample of 400 observations were taken from a population with a standard deviation 15. So the population is having standard deviation 15. So you have to identify whether you are given the population standard deviation or sample standard deviation. Based on that, we will be writing the test statistic. And you are asked to test the population mean, and for that you are given the sample mean. That is, if the mean of the sample is 27, that is x bar is equal to 27. Test whether the hypothesis that mean of the population is less than 24. That is, we have to test whether mean of the population is less than 24. So I have already told you that whenever you are given the keywords like less than, greater than, increase or decrease, we will be taking this into our alternative hypothesis. So our null hypothesis will be H naught mu is equal to 24. That is, we are asked to test whether our population mean is 24 against our alternative hypothesis will be, here you are given less than. So we will be taking this into our alternative hypothesis. H1 mu less than 24. So H1 mu equal to mu naught. That means our mu naught is 24. And we are given alpha is 0.05. Now what will be our test statistic? So we have already discussed this. That is, when n greater than 30, sigma naught, our test statistic will be x bar minus mu naught divided by sigma by root n. So we can take Z as, so the test statistic is Z is equal to x bar minus mu naught divided by sigma by root n. This follows normal distribution with mean 0 and standard deviation 1. That is, this follows standard normal distribution. So let us substitute the values and find the value of Z. So x bar is 27 minus mu naught is 24 divided by sigma is 15 by root n is 400. So root 400. So which is equal to, let us find the value of Z. So 27 minus 24. I am finding this by putting brackets. Okay. So don't forget to put brackets when you are doing the calculations in the calculator. So divided by root of 400. So close the bracket. So you can see that I have put brackets while doing the problem. Okay. So 4 is our test statistic value. So which is equal to 4. Now you are given alpha. So given alpha as 0.05. If you are not given the value of alpha, you can take it as 5%, 0.05. Okay, if alpha is not given, you can take alpha as 5%. Okay, now this is our alternative hypothesis. So since this is our alternative hypothesis, what will be our critical region? So we have already discussed that. That is, if our alternative hypothesis is mu naught equal to mu naught, modulus Z greater than or equal to Z alpha by 2 will be our critical region. If H1 mu greater than mu naught is our alternative hypothesis, Z greater than Z alpha will be our critical region. And if H1 mu less than mu naught, Z less than minus Z alpha will be our critical region. So here we are having this case, that is H1 mu less than mu naught. So our critical region will be Z less than minus Z alpha. So the rejection region is, or the critical region is, Z less than minus Z alpha. Okay. Now we can find this value of Z alpha by probability of Z less than minus Z alpha equal to alpha. So you can substitute the value of alpha here and you can find the area and fix minus Z alpha, or otherwise you can by heart these values, that is when alpha is equal to 5%, value of Z alpha is 1.645. So from tables the value of Z alpha is 1.645. So Z alpha is 1.645. So minus Z alpha is minus 1.645. Okay, now let's see what happens. So Z is equal to 4, which is obviously greater than minus 1.645 Z alpha. So this is not true. If this is true, we will reject the null hypothesis. Since this is not true, we will accept the null hypothesis. Okay, so we conclude that what the population average is 24. Okay, thank you.